First of all, I'd like to welcome you all on the Cloud Lab 1, talking a simple go up through Docker and Kubernetes to Google Cloud. My name is Maciej Ogrodnik. I am not the Ken Lomax. Ken Lomax will lead this presentation and this lecture. I am person responsible for Hack Your Career initiative. I am one of the coordinator, and I will guide you through this the beginning of this lecture. So on the agenda today, we have, first of all, the intro about this initiative. Then, of course, Ken will give his lecture. I still left in this agenda the networking part. Though it is difficult to network online, I hope we can still get to know each other and talk about some of the things that you would be potentially interested in. Afterwards, we will go to Q&A. And last but not least, I would ask you to complete the survey on this lecture. And also, I will invite you to a game of Kahoot. If you are not familiar with it, this is a simple game that will test your knowledge about this very lecture, and there will be also prizes. And the Hack Your Career. So basically, Hack Your Career is an initiative that for the students to expand their knowledge on some of the topics we are familiar or expert in. This semester we have the agenda quite packed in because we have 6 lectures. Regular we have 4 or maybe 5. Of course, due to the situation, the worldwide situation, we have it all online. And I will not guide you from every topic that we have here, but I will also ask you to visit our GitHub account or our Facebook webpage. And if you are quite interested in any internship in Sap Labs Poland, then you can hear more about the Team Hack. This will be the next lecture. The Team Hack is basically the initiative that we put a group of people who are on our internships, and we ask them to do some project for us. It will be, of course, let's say, in the office regularly, but now in the home office. But you will be grouped into this, let's say, task force who will do some cool stuff for us with, of course, guidance of our senior guys. And last thing from my side, so Sap Labs Poland, the place that most of us are based in. Unfortunately, Ken is not. That's a really pity. And what can I tell you about it? So this is one of the 21 strategic labs that are worldwide. SAP, in contradiction to other companies, does not have like 1 or 2 development areas. It has 21 actually. And in Gliwice, there is more than 350 employees, and we have several domains that we operate with. So we all originated from commerce. So e-commerce still is a big part, but we also have the social commerce. So this is basically integration with Instagram, with Facebook. We have cloud platform and a lot of projects that are done on the open source. The development languages quite vary because we have Go, we have Java, we have Angular, and potentially a lot of more that we simply don't list because there are too many of those. And most of our solutions are cloud native. There is also a variety of specialization that we have in our office because we have product teams, we have project teams and innovation project teams, and of course the support. So if you look from the software lifecycle perspective, you can see that actually we have full life cycle in Gliwice. And last but not least, for our employees, we have several education opportunities where you can pass a certification in Sap Labs Poland. You have education platforms such as Pluralsight, LinkedIn Learning, many internal ones. And of course, since SAP is a big company, we have more than 100,000 people worldwide, you also can have access to all of those experts that we have. And that is from my introduction. Do you have any questions on that? If no, I will stop sharing and I will pass the presentation to Ken.
Great, thanks much. So I need to share my screen. There we go. Okay, do you see my screen?
Yes, we can.
Yeah. Great. Okay. So yeah, thanks very much for that and welcome everyone. Very happy to give a talk in Hack Your Career. It's my first one. And what I'm going to share with you is what we call a cloud lab. And before I forget, if you have any questions, do shout out. Otherwise, it's like speaking into a black hole. What these cloud labs are little workshops. We have about 20 of them now that I've built up over the last couple of years. And it's all about giving attendees insight into 1 or 2 or 3 technologies and a little journey, what I call a sort of end-to-end journey. So we'll be going on a little journey here, and in that journey or along that journey, you'll find out a little bit about Go, about Docker, about Kubernetes, and about Google Cloud. Yeah, the reason behind this is that at SAP, we've got to learn a lot of new technologies, and it's often the case that whenever you learn something new, you trip up all the time and have problems and problems and problems, and it's very frustrating. And so the idea of the Cloud Lab is to give attendees a successful experience with new technologies by exploring some useful, non-trivial end-to-end journey. Yeah. Okay, so I believe Matt Chechers has shared a PDF with you. You don't need to read it now, but that PDF, if you view it online, has a lot of links that are very useful. And in this Cloud Lab, as is typical for these Cloud Labs, there's the main material, the main journey that we'll be following down the middle column of this page. But on the right-hand side are a load of carefully selected but excellent links to find out more. Yeah, because of course you can go to Google and type in Go or Docker or whatever, and you'll just come up with thousands of links. And what I've done for this Cloud Lab is carefully select very, very good links. So if you're interested in finding out more about any of these topics in particular, as we go through it, you'd be well advised to just follow the links on the right-hand side. Yeah. Okay. So as I mentioned, in this Cloud Lab, I'll be coding. So it's not a PowerPoint airware thing. I'll be doing live coding. And when you get the PDF, you'll be able to do it yourself, because the PDF has all the steps I'll be doing in that document. But so you don't lose track of where we are in the journey, it might be useful for you to keep this in mind. This is an overview of the journey that we'll be following. So what I'd like to do is just describe this journey to you, and then we'll actually start going through that journey step by step with some live coding. The journey starts at the top of the page, as you might expect. And what we're going to do is code a little Go program. That Go program will actually be a little HTTP server that returns a hello world to the caller, whoever calls that little HTTP server. Once we've created this Go file, we'll build it. That will create a little compilable program, which we can then run. And then once we've run that program, once it is running, we can access it, right, via a little web browser, and we'll see hello world, and we'll also see the name of the machine on which the program is running, because that will actually turn out to be an interesting thing. So that's the first step, is to write a Go program, compile it and run it and access the web page. Yeah. Once we've done that, we're going to add a Dockerfile. The Dockerfile will be called exactly Dockerfile with a capital D, because that is what Docker expects. And what Docker does is it will compile this Go program into a program, into what's called a Docker image. And that Docker image can be executed on any Docker machine. This will all make a bit more sense once we start to go through it. But just keep in mind, but we'll start with the Go program, we'll run it, then we'll add a Docker file to Dockerify this project. Once we have this Docker file alongside the main.go program, we will use the Docker build command that will build for us a Docker image, which we can then run, and we will run it. We can also push this Docker image to Docker Hub. It's a bit like GitHub for code. So we can push this image to Docker Hub, where anyone in the world, including ourselves, can then pull it from Docker Hub, and we'll be doing that as well. So we'll build this Docker image, we'll push it to Docker Hub, we'll pull it back from Docker Hub, and we'll be executing that Docker image. What we'll do then is we'll bring Kubernetes into the picture. And Kubernetes requires a file called deployment.yaml. That file, which we'll be writing, will describe what we want Kubernetes to build. In this case, we want it to build, I think, one service that will be executing this HTTP server program. So we'll write this deployment YAML. Yeah, and then we'll be able to run. We'll use the command kubectl, which allows us to access Kubernetes commands. We'll use that to create a Kubernetes image that we can then also run locally on something called Minicube, which is a sort of local Kubernetes environment. And finally, we'll be running this Kubernetes application on Google Cloud. So there are a lot of steps in this journey. It might be confusing at the moment, but maybe now you'd like to download that PDF just so that you can refer to this image should you want to, should you be a bit lost at any point during the journey. But that's the big picture. Create a Go file, run it, Dockerfile it, run it again, and we run it using the docker run command, access it again, and finally turn it into a Kubernetes application, run that locally, run it in the cloud, and access it again. That's the sort of story that we're following. Hopefully that makes a bit of sense. Let's go back to the Cloud Lab. Okay, and then again, once you have the PDF and you want to go through this on your own, this Cloud Lab has been tested on a Macintosh, which is the laptop I have. You can run it on Windows. If you have a Windows machine, you probably want to follow these steps first, which is to open up a Google Cloud account and simply run all of the following code in Google Cloud itself. We'll actually be following this step later in the journey. But if you have a Windows machine, you might want to do this first of all. I do not. I have a Macintosh, so I'm going to be starting from here. And I'll just be following the steps. So again, you can do this on your own at a later time should you follow the PDF instructions. Okay. Now, this Cloud Lab assumes that you have installed Golang. And as I mentioned, the PDF has live links. So you can, for example, go here and you'll find out how to install Golang, right? It's very easy. Just download it, install it. Once you do that and type in Go, it should return something other than command not found. So this tells us that Go is installed. And I've just created a directory called Software Academy, and that is where we are. What I want to do now is create a directory in which I'm going to start coding. I'll call that directory Cloud Lab 1, and I'll cd into it. So there we are. And what I want to do now is create a file called cloudlab1.go. Before I do that, I'm going to create a Go module. Doesn't matter about the details. Modules are all about dependency management around Go. I'm going to tell Go that I want a module called cloudlab1. So if we now do an ls-la where we are, we can see that this command just created this file for me. Don't worry too much about what it is, but just out of interest, it's simply it's informing Go and anyone who might use this Go module what this Go module depends on. And currently it depends on nothing else other than Go, which is perhaps not a surprise. So all good so far. What I want to do is create a file called cloudlab1.go. I'll just use a little VI editor for that. I'm going to copy this and then I'll describe to you what it's doing. Put that in here. So we now have a file called cloudlab1.go. And what is that doing? Well, maybe we'll look over here where the code's maybe a bit more readable. If you know Java or Go, you need a package around your code. And then we're importing various imports that we'll be using in the little bit of code below it. So what is the code doing below? Well, this is the entry point. If you're familiar with C or Java or Go, you might not be surprised to see that main is your entry point. We're going to define a variable called port, which will be set by default to 8080. If the user has set an environment variable called port to something else, then that will override this value of 8080. So it's just a little convenient way of allowing this program to set a port and for that port to be overridden from outside should you want to. But we haven't done that. So at this point in the program, we've created a port whose value is 8080. Then what we do is we create an HTTP server. And if you're new to Go, and maybe you're more familiar with Java or other programs, this might be refreshingly simple to you, surprisingly simple. This is all you need to do to create an HTTP server. And I'm able to use this HTTP package because I've referenced it up here, right? I've imported it, HTTP. So here we go. I've created an HTTP server. And then what I'm saying is I want this server to call a function when that server is hit at its root path. Yeah. So I'm, if you like, creating an endpoint for this server. When this server is called from outside, this function called hello, which is here, should be invoked. Yeah. And you might not be surprised to see that this server function has a request and a response. Yeah, as you might expect. We actually start the server here. So we've initialized the server. We've given it an endpoint and a function that should be called. And then we actually start it here. And if all goes well, it will never get any further. If there's a problem starting the server, the code will proceed to the next line where it will log a fatal error message. The error having been returned from an unsuccessful call to listen and serve. So there are a lot of nice features about Go. I really like the Go language. If you and Maciej like, I could give a Golang Cloud Lab sometime, perhaps. It's a really nice language. I recommend having a look at it. This is the guy who wrote Go. That's worth looking at, a little YouTube from him. Okay, and so what happens in this hello function? So if you hit this server at the root address, this function is called. It's passed in the request and the response. And all we do is we'll log something to the output console saying we've been called. And we'll also write hello world. So anyone calling this endpoint should see hello world. And they should also, interestingly, see the host name of the computer that this program is running on. Yeah, that's all it's doing. Okay, but it's worth understanding what this program is doing because it forms the basis and is informative about what happens with Go and Docker and Kubernetes as we proceed. All right, so we have a little program. That program is going to open up a web server. That endpoint, when that web server endpoint is called, it will invoke this hello function, and that hello function will return hello world and the name of the computer on which this program is running. So good so far. Let's run this program. We can do that with the go run command and the name of the program. And it says, do I want to allow it access? Yes. And it tells me the server is listening on port 8080. Well, that's hopeful. So if I go to localhost 8080, I see hello world, right? Hello world. And this funny thing, well, if I go to about this Macintosh, I will see that it's the name of my computer. Yeah, probably no surprises there. The web page is returning hello world as specified here, and it's returning the host name of the computer on which it's running, which really is my laptop. It's showing the Jenkins icon because my web browser has cached that from earlier in the day when I was running Jenkins on that website, interestingly. All right, all good so far. And if Perhaps you're familiar with the curl command. You could also use the curl to access it, and it's the same story. We'll get a hello world and the name of the computer. All right, so if we come back up to this little overview here, all we have done so far is created a program actually called cloudlab1.go. We've built it and we've run it and we've accessed the endpoint. Yeah, so we've done this first step here. Let's close that page. Come back down here. All right. Now, what is perhaps interesting is by default, a compiled Go program will link to the required libraries dynamically at runtime. This is fine if you compile and run your program on one machine, but if actually you compile this Go program on, let's say, my Macintosh, but you want to run it on a Linux machine on Google Cloud, you're going to run into problems because it will try to download some dynamic libraries at runtime that are probably a different type, or it will try, for example, to download Macintosh dynamic libraries and run them on the Linux machine, and that will get into all sorts of difficulties. What we can do to address that is, rather than saying go run cloudlab1.go, we can say go build. So we're going to build, we're going to compile this program. Not only will we compile it, but we will compile it to run on Linux, because we're going to run this in a moment on Docker, and Docker images run on Linux. Okay, and there's a lovely article about it here. If you want to read more, you can go to this link, which should be working on your online PDF, and that will take you to a good explanation about why you need these additional environment variables. But if I copy and run that command, so I'm going to Control-C out of that and compile that, we will have an executable that can run on a Linux machine. Let's allow that to compile, and I'll do an ls-la, and we can see that we have a new program, a new file, cloudlab1, that's an executable, and that is our Linux executable, which I can run like so. I think because I'm on an OS X machine, this will also run directly on the Macintosh. And here we are, same story. It's saying, do we want to allow access? Yes, I do. And if I say curl, again, I get exactly the same output as before, hello world. And not surprisingly, it's still running on my laptop, right? So probably no surprises there. And let's Control-C. What I want to do now is what is called containerize my Go program. At the moment, it's just its own little Go program that will work on my machine, but I would like to make it a Dockerized or containerized Go program. And to do that, what you need is a Dockerfile, and it needs to be written exactly like that with a capital D, one word. Let's do that. Let's make a Dockerfile alongside the Go program. Some very good links on Docker are here. This one is excellent. I mean, they're all excellent links, but if you want to find more about Docker, follow the links on the right-hand side. You create, oh, what did I do there? I think I'll do that again. It made me nervous. There we go, that's right. So we now have a Docker file. Docker files always follow this sort of format. You describe from what Docker image you would like to extend your own Docker image. And I would like to extend or build my Docker image upon the Golang Docker image. And that itself was built on another Docker image, all the way back to a base Linux image. So these Docker images are built in a sort of layered architecture, and you choose the one that you want, that is closest to the one you want, and you extend it a little bit. So what I've done is I've chosen the Golang Docker image. And if you go to Docker, you'll find that the Golang Docker image is a useful Docker image to run Go programs on. That sounds good to me. That's what I want. So I've built my Docker image, or extended my Docker image from the Golang Docker image. And what I want to do is I want to add my files, in particular, I want to add Cloud Lab 1 to a directory in my Docker image called app. That's what this is doing. It's going to copy actually it's going to copy all of these files into a directory called app. And then it's going to set the working directory to that app directory. And then it's going to run this command that you might recognize from before, go run cloudlab1.go, which actually is what I ran up here, right? So you can sort of think of this as a runtime command telling that there's enough information here to tell Docker how to build a Linux application and execute it. We're going to be extending the Golang Docker image. We're going to add the files that it's going to need. We're going to cd or change directory into this app folder where all these files will be. And then we're going to run the command go run cloudlab1.go. So these are the files we currently have, the Dockerfile that you've just seen here, the cloudlab1.go, which has the code that we wrote earlier. This is the compiled executable ready to go, and this is that dependency file that I showed you at the very beginning. Once we have created our Docker file, we need to build our Docker image, and you need to have Docker downloaded on your computer. I have mine downloaded here. That's what this little icon is, and you'll need to do that yourselves too. You'll need to have Docker. If you haven't, there's a link on the left-hand side how to do that. You need to have Docker installed. Once you have, what you want to do is, maybe I'll do this step by step. I want to build my Docker image, and you do that using the Docker build command. I want to give that Docker image a name, and the convention is to, I mentioned at the start that you can push and pull Docker images from Docker Hub. Now, if we go to dockerhub.com, you can create an account there. And in that, you'll have a username, right? And that username, by convention, is what is the prefix of the Docker image name that you specify right now. So my Docker Hub username is Ken Lomax. So I'm going to give, I would like to build a Docker image with the name Ken Lomax / and then I'm going to call it CloudLab1. You want to give it a version. This is the first version, so :v1. And I need to tell it where the Dockerfile is. Well, the Dockerfile is right here. Yeah. So with this command here, I'm able to build a Docker image. It will be called Ken Lomax / CloudLab1. It will be version 1, and the Dockerfile is right beside us. So if I hit return, that will actually go off and it will examine the Dockerfile, and it will use that Dockerfile to go and create this Docker image. Here we go. You'll also get used to seeing that it does this in layers. If you read up on Docker, you'll find that Docker images are based, as I mentioned, on layers. You choose the most close to what you require, but that image itself was based on another one, and that was based on another one, and so on until you get down really to a root Docker image that might just be an executable Linux machine. So this is pulling, you might see there, it's pulling from the Golang. So it's pulling the Golang Docker image, and then it's extending it with the extra commands here. So that won't take long. What it will have done is built a Docker image. That Docker image is just local on my machine. It's not anywhere else yet. If I now type the command Docker images, you can ignore some of these. I've been playing with Docker earlier today. This is the one that was created 5 seconds ago, right? And this is the one that we need to focus on. This is Ken Lomax / CloudLab1 is the name of the Docker image. It's version 1 is its tag. Yeah, and it's not tiny, but it's a complete executable that will run now, yeah, on a Linux machine. Okay, I would like to run that. Now, when you install Docker on your machine, what it does is it creates a virtual machine, a Linux virtual machine, and it will run your Docker images on that Linux virtual machine. To run your Docker image, you need to use the Docker run. Then there are various little flags, which I don't want to confuse you with at the moment. But this one is fairly important. What we're telling Docker is that when we hit our Docker machine at port 8080, it shouldn't map that to any other port. It should keep it as port 8080 and pass that request into my Docker image on port 8080. So it's just passing my request 8080 through to port 8080. I might show you what the consequence of changing that in a minute, because it's informative. Now we need to provide now the Docker image that we want to execute, and it needs to be the exact name there that we specified earlier, Cloud Lab 1 version 1. So hopefully, if we now execute this, it will give us some curious thing here. But hopefully, I can again curl localhost 8080. Yeah, but look at this. This may be interesting. This is no longer the name of my laptop, right? So as far as this HTTP server is concerned, it's not running on my laptop. And that's sort of correct. It's actually running within Docker, yeah? So that's interesting. If we come back up here to that image, we're now at this step here. So we've built a Docker image that has a name whose convention tells it where it could be stored on Docker Hub. It could be stored on the account Ken Lomax, which is my account. We haven't yet pushed it there. And we're running, so we're right at this stage here. I've used the Docker run command, and it is running. Now my Docker image, and a running Docker image is called a Docker container. So we now have a running Docker container running on this Linux VM. And when I now hit the Docker machine on port 8080, because of this mapping here, it's forwarding it on the same port. I could have changed it to another port, but it's forwarding it on 8080 to my Docker container, which is running the program. It's running the program because the first thing it did when it booted itself up was run the command go run cloudlab1.go. So it is running my little Go server, right? And when it's hit, it returns hello world and the name of the host. But as far as this HTTP server is concerned, the name of the host is this Linux VM. It's not my laptop. So that's interesting and hopefully informative that we're now able to hit the machine, and it's, as far as the server is concerned, it is not running on my laptop. Now, let's just try a couple of things because I think it's informative to sometimes deliberately break the demo. I'll just come back down to where I was. Yeah. If I do a Docker PS, that will list the running Docker images or Docker containers. We can ignore this one here, but here's the Cloud Lab one. And I can stop it. I can say Docker stop and copy paste the container ID. Right. So now if I curl this, then in a moment it will stop. There we go, it stopped. So I can now no longer hit the machine. Now what would happen, for example, if I had said this instead? Let's see, I'm going to run this. And I'm going to say map from 8081, port 8081 to port 8080. Let's see what the consequences are of that. So that started. And now if I curl the localhost 8080, it says connection refused. If I curl 8081, it hits the server. Now this is interesting because the server itself is still listening. Sorry for all this scrolling, but I just have a smaller screen. the server is still listening on port 8080, right? Yet I had to call it on port 8081. Why is that? Well, it's because of this command here. I have told Docker that when it boots up this container and is running this container, it should listen to externally to port 8081. If it hears anything on 8081, forward it inside on port 8080. Yeah, and this can be very useful because you can imagine you might have a lot of different services running, and by default they're all on port 8080, for example. And using this sort of trickery, you're able to spread out the ports as you want. Now, let's do a Docker PS again. Again, I could stop this like so, but rather than do that at the moment, what I'd like to do, let's come back down to where I was. I would like to log in to this machine. You can imagine if you've got a more complex application running and you want to see its logs, or you want to do some debugging, you would like to log into that machine and navigate around. And you can do that very easily. So again, you just do a Docker PS that lists the Docker containers that are running. This is the one we are interested in. And what you can do is say, I would like to execute a command. Again, don't worry about those flags. Pass in the ID of the container. And what command would I like to execute in that Docker container? Well, I would like to execute a bash shell, right? So what happens if I run that? Well, it takes me into that machine and is running a bash shell. And that could be extremely useful. If I do an ls-la here, there are the files that it copied in, right? But I'm no longer, this is not doing an ls on my laptop, it's doing an ls directly on the running Docker container, yeah? And you might notice that we're in the app folder, right? Why are we in the app folder? Well, maybe if we come down here, Cloud Lab 1, and look at the Dockerfile, you might remember that I said, please copy all the files into a folder called app and change directory into that app folder. And that is precisely why we are now in the app folder. Yeah. And if I were to do something like a PS minus AUX might work. Yeah, we can see there's the Go run that is currently running. Yeah. This is all really, really cool. So I might not look it, but I'm exceptionally old. And when I was at university, to run these sort of programs, you had to go to the IT department and you had to know about all sorts of computing stuff and have admin rights. And but now with Docker and the cloud, you can create all the machines you want, log into them, look around just from the convenience of your laptops. Very, very cool. So I'm going to Control D out of that. And let's do a Docker PS. And again, stop that one. Takes a minute. So we're now, we've come down here. And again, you'll have all of this as a PDF, so you can go through it yourself, should you like, afterwards. Yeah. So now I'd like to talk about Docker Hub. What I might do is copy this image, open this image up on another tab, because I keep wanting to refer to it. No, that didn't work. Okay. What I'd like to do now is push my Docker image to Docker Hub, because then anyone literally in the world who is running Docker can then immediately execute this program. And it will be useful for the next steps when we go to talk about Kubernetes. So I would like to push this Docker Hub, this Docker image to Docker Hub. That's what we'll be doing next. I'm going to try to keep that one open and open up another tab. Good. Okay, let's come back down to where we were. Hopefully you're not getting too dizzy with all the scrolling. Now, I mentioned before that if you want to follow this Cloud Lab, you need to have a Docker Hub account. Let's go to Docker Hub. Just type in Docker Hub. Actually, Hub Docker, confusingly, hub.docker.com, and you need an account. I mentioned that my username is Ken Lomax, and that is why I gave it the name Ken Lomax / because by convention, Docker Hub will Docker will know to push it to this account on Docker Hub. Yeah, should it be allowed? Should it be authorized? And the way you can authorize it is from your command line to type in the words command docker login. You do that, it will ask you to log in. I think because I've done that before, I will not need to give my password. It's just as well, because I often forget it. Oh, excellent, it does require it. That's marvelous. Docker login did not succeed. Now, let's see what happens when I try to push. Or maybe I'll try log out and then log in again. Docker log out, Docker log in. Good, thank goodness for that. Okay, so now I am logged into Docker, and I would like to push my image. And again, Docker knows that this is the username of your Docker Hub account. You might recognize that this is the name of the Docker image I created, and this is the version of the Docker image I created. Okay, so I'm going to say Docker push the username, the name of the image, and the version of the image. And if we say push, it's going to push that, and you might not be surprised to see that again, it is following this sort of layered approach, and it does all sensible caching. So if it notices that the bottom 5 layers have already been pushed, it won't push those again. And similarly for pulling, Docker will look after caching everything that it can. You can override it should you want to. You can see here that it did exactly that. It noticed that these layers already exist on Docker Hub, and it only had to push the very top layer. That's good. If I now go to Docker Hub, I will see that it has this Cloud Lab 1. I think if I refresh, it will say it was updated just now. Yeah, updated a few seconds ago, and it's public. So this is cool. What that means is that anyone, you would need to have Docker Hub running, but I can share it in. How do I get to the chat window? Oops. Chat. So if you have Docker running, you'll be able to run this now. And I'll run it now. But anyone literally around the world can now run this. So let's try that. That is hopefully running. If I now do a curl localhost 8080, there we are. And again, notice that the host name is not the name of my computer, right? It's the name of the virtual machine that this is running on. So that's all hopeful so far. And again, as per standard Cloud Labs, excellent links from the right-hand side if you want to find out more. What I'd like to do now is wrap it in Kubernetes. If we come back to this image, I've run the Docker container, the Docker image, and a running Docker image is called a Docker container that runs upon a Linux machine. That's all fine, and I've also pushed it now to Docker Hubs so that anyone in the world, including me later, will be able to pull that image from Docker Hub, yeah, and execute it. What I'm going to do now is create a deployment file, because we're going to make this a Kubernetes project. Let's come back to the Cloud Lab. I mentioned we need a file called deployment. We're back here where we've got our Dockerfile and our Cloud Lab program and Cloud Lab executable. And I'm going to create a file called deployment.yaml. YAML is this format. It's you may or may not be familiar with YAML. YAML is quite nice and succinct. It just insists that you have 2 spaces or 4 spaces or 6 spaces when indenting your code. And it takes a bit of getting used to, but once you're used to it, it's quite natural. I'll just paste that in there, and then I'll describe a bit of what we have. Again, this is an excellent presentation by a woman called Megan on Kubernetes. She describes really nicely what these are, why they work, how they work, why they're needed. So I really recommend you go and watch her presentation. It's really excellent. Now, so there's quite a bit of noise in this file, but this should look familiar, right? That's the name of the Docker image that I created earlier and pushed to Docker Hub, yeah? So that's perhaps the most important thing, is Kubernetes will know where to find and download the Docker image, right? It will then run that Docker image, and it will in fact run 2 of those Docker images. So Kubernetes will boot up 2 servers. That's cool. But the whole idea behind Kubernetes is that it looks after booting up microservices for you and looking after you if things crash. And so if, for example, one of these services crashes for whatever reason, Kubernetes is always behind the scenes making sure that everything is healthy, and it will boot up a second microservice. So when we first boot up this deployment, 2 microservices, 2 HTTP services will be created. And they will be this Docker image that we've been playing with up until now. There will be 2 of them, and if for whatever reason the machine crashes, the service crashes, whatever, Kubernetes will kick up a second or 2, which is a very powerful concept. So what you do in Kubernetes is you describe your deployment in this format, and it will ensure that that deployment is satisfied. And if for whatever reason something dies or crashes halfway through, it will make sure that for example, 2 microservices always exist. And we'll see an example of that later. Now, the point here is our HTTP server is of a type deployment. And deployments are what they call ethereal. I think that's the right word, meaning they can pop up, they can be killed, another one can come up and be killed, or crash for whatever reason and be brought back up. And what that means is that the endpoints, the URLs of these microservices are not very stable because they're always changing, right? It might crash and another service comes up with a slightly different URL. And so what in fact we want is, we do not want to access these 2 microservices directly. Rather, we would like Kubernetes to have a load balancer in front. So here we see load balancer. We would like Kubernetes to have a load balancer in front of these 2 microservices, right? And this load balancer will have a steady URL. And Kubernetes will make sure that that load balancer is alive and kicking, and if it's not, it will reboot it quickly. And so what we'll be doing actually when we deploy this little solution to Kubernetes is we'll be accessing this service, and this service will forward requests to one of the deployments. Yeah, hopefully that makes a bit of sense. Let's perhaps see that in action. Now, what you can do, and it's advised, is to download Minicube. Minicube is a little Kubernetes application that can run on your laptop. And the idea is that when you create a Kubernetes solution, you try it out on your local Minicube application. Once you're happy that that is working, you can deploy it to a fully fledged Kubernetes solution out there in the cloud somewhere. So again, this Cloud Lab assumes that you have installed Minikube. It's easy to do, just follow the links here. Once you do that and you type in Minikube, you should see something other than command not found. And then you have to say Minikube start. I think I have already done that earlier, but Minikube start, make sure that Minikube is running. Maybe I'll keep that in its own little window. I'll open a third terminal. And the way you talk with your Minikube is with kubectl. So for example, if I want to look at the running services, I can say get services. And the only service running currently is Kubernetes itself, which is not something that we've created, it's Kubernetes itself. All right, that's good. Minikube has a useful dashboard that you can look at. We'll see that in a second. I mentioned that kubectl is the command line interface you use to talk with a Kubernetes application. You might have a few of these Kubernetes applications running. If you want it to talk to Minikube, you should run this command, which I had actually run earlier, which is why happily it did talk to Minikube by default. But if not, you need to tell kubectl to talk to Minikube. Yeah. So again, if I list the services, only that is running. All right, and if I, for example, want to look at the deployments, has anything been deployed? No, nothing has been deployed. And the Docker containers run in what are called pods. Let's see if there are any pods currently running. No, well, that's sort of to be expected because I haven't yet deployed anything to Minikube. Yeah. Also, Minikube has a useful dashboard. The way to open that dashboard is to say Minikube Dashboard. I'll do that here. And that opens up a nice little dashboard. And here we can see we have some things that might start to look familiar. So earlier I asked it to look at the pods. Well, I can also look at the pods here. There are no pods at the moment. I can look at the deployments. There are no deployments. And I can look at the services. And the only service running is Kubernetes itself. Yeah. All right. Let's come back here to this one. Now, you might remember that we have a file called deployment. And I would like to tell Kubernetes, or Minikube, about this deployment. I would like it, please, to go and deploy this, right? And what it will hopefully do is create 2 microservices based on this Docker image and a load balancer in front of it. Yeah. And the way I do that is I use that kubectl command. Kubectl, I say apply, or I think I can say create, actually, create, and then I need to give it the name of the file with the -f flag, and it's called deployment.yaml. So there we are, kubectl create this deployment. And this looks hopeful. It's saying that it's created a service, which is our load balancer front end, and it's created, yeah, our microservices, so actually 2 microservices. Now let's go back to that dashboard and see what's been going on. If I go to deployments, which is here we can see we've got this deployment. Well, that's good to know. It's got 2 pods. That's because we requested 2 replicas, 2 microservices, if you like. If I look at the pods, here are the 2 pods. If I look at the services, here is the load balancer, right? Now let's come back here. Yeah, and I explored the pods and the deployments and the services via the dashboard just now. I can, as I did a moment ago, also do it via the kubectl. So here we have 2 pods in status running. That's hopeful. Kubectl gets services. There we have our load balancer, right? That's our front end. And also if I were to do get deployments, there, that shows our deployment that we had. Now let's go back to the services. I would like to hit that load balancer, right? I would like to access that load balancer. Now, interestingly, because we're running on Minikube and not a fully fledged Kubernetes application, this load balancer is not going to get its own external IP. There's a nice discussion about that in the Cloud Lab. But one way to access the Cloud Lab service is to ask Minikube to connect us to it itself. And I think, yeah, I say Minikube service, and then copy paste the name. So I'm asking Minikube, please give me a link to this load balancer. And if I hit return, it will do all the mapping behind the scenes that are necessary and give me the endpoint. And here it is. And once again, notice that it's returned hello world and another host name entirely, right? Because this is running on some Docker container inside Kubernetes. So I've not really got any idea about that name. It's certainly not my laptop, but this is a running microservice in Kubernetes. And interestingly, yeah, well, let's try that. It may or may not swap between 2 host names, because you might remember that we are now hitting a load balancer, and behind that load balancer are 2 microservices, right, running this program. And so I don't know how the load balancer is configured at the moment, but it might be the case that if I were to refresh this a few times, it might go from one service to the other. Though it looks at the moment like it's always going to the same service. But this is cool. We now have a more stable, if you like, architecture. We have a load balancer with microservices behind it. And what is particularly cool is if we go to our pods, or sorry, rather here, I think to the deployment. Yeah, let's say it's now Christmas, and my incredibly popular microservice is getting hammered by a lot of users, and the CPUs are burning up, and I need to have more microservices behind this load balancer. All I need to do there is scale it. So I go to my deployment and I say scale. And rather than 2, I might want 5 microservices. What's really useful is that it also tells us how we could also do this from the command line, which I think is a really nice feature. So let's say I want to scale this up. Let's come back over here before I do that. I'm going to say kubectl get pods, and I have 2 running pods. And I'm going to say I want 5. And let's go and run this again. And we can see that it's already creating 3 new ones, right? And it actually does it very fast. So there we now have 5 running microservices. This is exceptionally cool. This is what Kubernetes is all about. It's allowing you to describe your deployment, and it will go ahead and do the work for you. And then let's say Christmas has passed and I want to go back down to 2. We can do that. And again, if we're quick enough, we'll see that it's terminating 3 of these services. And yeah, in a moment, they'll disappear altogether. And as I mentioned, if one of these is killed or dies, or the machine crashes or whatever, Kubernetes will make sure that a second one is brought up. And you will have noticed that it's very, very fast. It takes longer to terminate these services, but it brings them up exceptionally quickly. So that's a really useful way to, start having a more complex architecture with load balancers in front of microservices. All right, so we are now at that point. We have deployed to Kubernetes and run it on Minikube. But now I'd like to really run it in the cloud, and in this example on Google Cloud. I get rid of that. Let's come down here. Right, at this point, so we're now going to go to Google Cloud. And if you want to follow this yourself, you'll have to create a Google Cloud account. They're free for up to a year and or $300 worth of use. And I'm probably not supposed to, but I've created many of these. Yeah, so it's no problem. All you need is to give your credit card details. They're not used, but whatever. It takes that. But you can very quickly, within 5 minutes, get a free Google Cloud account. Let's go to my Google Cloud account. I think I'll open it in another window. So I've gone to cloud.google and I'm going to open the console. That's because I've killed my project earlier. That's fine. The first thing you need to do is create a project. And I'm going to call it Cloud Lab 1, I think. Let's see if that works. I really like Google Cloud. I've played around with Azure as well. Getting used to Azure. I haven't yet used Amazon Web Services. I'm sure that's also very friendly, easy to use. Okay, so this is creating a new project on the cloud. And I am going to be running my Kubernetes application, right? Now, by default, you're not allowed to do that. And Google needs to track and limit what people are allowed to use, and you need to request it so that eventually, after this trial period is over, you get charged for it. Now, to do that, you need to go to. So I hit that little hamburger menu. If ever you're lost in Google Cloud, go to that hamburger menu. I would like to activate some APIs. So I have gone down to APIs, Dashboard. And I would like to search for and activate the Kubernetes API. So I'll type in Kubernetes Engine API. Yes, I would like to enable that, please. There we go. I've clicked enable. While it is doing that, I would also like to enable Compute Engine, because that is what will allow me to run a virtual machine. Compute Engine. There we go. And I'll click enable. And let's go back home. There. What's really nice in these cloud portals is you can get a little cloud shell. So I click the little cloud shell button there. And it will open up a little shell where I can directly work in a small virtual machine on Google Cloud. There we are. There's not much here. And I can toggle between the command line here, or if I go to the editor button, I have a familiar looking window into, sort of explorer window, right, into the files that I have. Let's go back to the terminal. I would like, and just check where I am. I would like to create a directory called Cloud Lab 1. I'll cd into it. So now I'm on a Google machine, right? I'm not on my laptop. This is a Google machine. I've gone into the Cloud Lab 1 directory. And what I would like to do is make a copy of this deployment file. So this is back on my laptop. I have this deployment file, and I would like to create that deployment file over here. And maybe one way to do that is just say touch deployment YAML. Go into the editor, find that file, and I'm going to copy paste in this deployment into it, just so that Google knows about it, so it's not just on my laptop. So there we are. I've got my deployment file on my virtual machine on Google Cloud. It's the same, exactly the same as it was over here. What is perhaps interesting is, again, Kubernetes will know where to find this image. And of course, my laptop was able to find it because I actually built it on the laptop and it was cached locally. But now Google Cloud will be able to find it. It will again notice this naming convention, and it will go to Docker Hub and it will pull down that image, right? Let's go back to the terminal. And back down here. So until now, we'd run this Kubernetes deployment on my laptop using Minikube. Now we're going to run this Kubernetes deployment really in the cloud using a fully fledged Kubernetes cluster. Okay, but it's the same commands. What I want to do is create a Kubernetes cluster. Window keeps getting in the way. Yeah. So I'm going to copy this. What I would like to do is create a cluster here. I have to authorize that I'm allowed to call these new APIs that I just enabled. And yeah, okay, this is actually, hopefully it's the error I'm expecting. Service contains data. I'm not sure. That might be because the services that I just enabled are not yet fully enabled. Let's go and have a look in the dashboard. If I again search for Kubernetes, oh, did I not click it? I thought I clicked enable. Let's try enable again. So I believe that I had not successfully enabled my Kubernetes Engine API. Let's wait for that to enable itself, and then we need to check again if it had successfully enabled the Compute Engine API. That's not normally a problem, but what I did want to show you is that in Google, and I think also in Azure and probably Amazon Web and the other cloud providers, if something goes wrong, it does normally give you a helpful error message, and even with often with a link. I'm not sure it's done at this time, but often it will give a so-called deep link in the error message, and all you need to do then is follow that deep link, click enable, and it will have resolved the problem for you. This error message looks a bit cryptic to me, and I think it might have been because the Kubernetes Engine API wasn't fully enabled. Okay, now it has enabled the Kubernetes Engine API. Let's check that it has also enabled the Compute Engine API. Compute Engine API. Yeah, that's enabled. It says enabled here. Now I'm hoping that that will now run. Yes, that's looking better. So that was a little surprising because normally when I run this command asking it to create a Kubernetes cluster, and I have not yet enabled these APIs, it normally returns with an error message taking me directly to these pages where I can just hit enable. But in this example, it gave me more of a curious error, which is a shame because I wanted to sort of advertise the user friendliness of it, but I probably did something wrong. But anyway, it's fine. I have enabled the Kubernetes Engine API, Compute Engine API, and I'm now creating a Kubernetes cluster to which I will be deploying this Kubernetes deployment, right? That can take a minute or two to work. Let's go back here while looking around. So the hamburger menu is always the place to go to when you're lost. And we can, for example, go to the Kubernetes engine clusters. And we can see that it's creating our Cloud Lab 1 Kubernetes cluster, right? With 3 machines, 6 CPUs, blah, blah, blah. All good so far. Let's get rid of that. And it's actually really nice to work in Google Cloud. So you immediately get your own. It's interesting, what's it doing here? No. Immediately can open your own Cloud Shell. Yeah, and start working on a Linux machine. And again, it's for free, up to 1 or 2 years use, up to $300 worth of use. It's very, very useful to just get working in. I don't know why it keeps returning. I haven't pressed return anyway. It's being created. It's also checking that it's healthy. I guess in addition to Kubernetes making sure that your services and your load balancers, your microservices are all up and healthy, it's checking that itself is healthy, which is a good thing. While we're here, let's have a look in the APIs. There's another Cloud Lab I could do at some point, which takes us through some other interesting journeys that involve things like cloud to speech, speech to text, and text to speech. But of course, once you're in, for example, the Google Cloud environment, you can start using all of the APIs they have at their disposal, right? Which gives you access to things like speech to text and image recognition, machine learning, and all that cool stuff. Okay, so we can see that the Kubernetes cluster has been created. If I come down here to Kubernetes engine clusters, there is the cluster. That's all well and good. And just to remind myself, I have the deployment file here, and that deployment file has a load balancer as it's at the front. And behind that load balancer should be 2 instances, 2 replicas of this microservice, right? And the microservice will be downloaded from Docker Hub, account Ken Lomax, and it's called Cloud Lab 1, and we want version 1. Now, if all goes well, I can just use the same command that I used on my laptop, which is kubectl apply, and I would like to use the deployment file. Let's hit return and see what happens. That looks hopeful. It says it's created it. Now this time, if I go to kubectl get services, we can see there's a load balancer, and it's still saying pending. But hopefully in a second, that pending will change to an actual URL that I can hit. While it's doing that, we can also explore it in the upper half of the screen. So if I go into the Cloud Lab 1 cluster, I can look around, see various things, logs, and somewhere should be the service. Maybe it's not yet fully up. Yeah, here's the endpoint. So it's already got a URL endpoint. Yeah, and now if I do kubectl get services, that pending has changed to a IP address. You might remember that on Minikube it did not change, right? It always stayed at pending, but because we're now in a fully fledged Kubernetes cluster, it has given me a URL with a port. If I copy that and go to it, I need to put a colon in there. Then once again, we have our running microservice. And again, some host machine that's certainly not my laptop anymore. And it may be the case now, though I don't think it is, that if I were to refresh, it might swap to the second deployment. But it looks like the load balancer is always taking it to the same machine. But that's very cool. We are now running in Kubernetes as I mentioned earlier, Kubernetes is all about making sure your architecture, your network stays stable. So if one of these were to crash, Kubernetes will make sure that it is brought up again. One last thing I wanted to show you is what's called a rolling update. Let's come over here. So I'm now back on my laptop, and I would like to adjust the microservice. Oh, sorry, not that one. I would like to adjust the one that I can actually read. So this CloudLab 1.go. And we're going to go fully international. Instead of saying hello world, we'll say bonjour world. Sorry, but I can't spell the Polish one. So bonjour world will now be our heavily modified version 2 of this microservice. And I need to build that into a new Docker image. How do I do that? Again, I say Docker build. I need to give it a name. Again, that name needs to follow that convention of the Docker Hub username, followed by the name, followed by a version. Now this is going to be version 2. And the Dockerfile is right here where I am. So Docker build, the name is Lomax/CloudLab1 version 2, full stop. So that's going to now build a bonjour world Docker image. I would like to test that locally before I push it to Docker Hub. Let's test it locally. You might remember that this is the way to run a Docker image locally. Again, I want to pass port 8080 into port 8080, and I would like to run version 2. Yes, this is saying it's failed because the port is already allocated. That's probably true. Let's do a Docker PS. It might be allocated because Minicube is running, or because this one is already running. Let's kill this one. So Docker stop that one. You'll see that that Docker image was running on port 8080. So I had to stop it. And that was version 1, right? That I had tested locally from before. Now I would like to test version 2. That has now successfully started. So if I curl localhost 8080, I now see bonjour world, right? So that's all very well, but the whole purpose of this was to get it up onto Google. And I would like my Kubernetes cluster in Google Cloud to be updated to use this bonjour world, but with no downtime. That's very important, right? I do not want any of the users using my amazing service to experience any downtime. I would like to make sure that Kubernetes smoothly rolls out this new version to all of the running microservices. I think at the moment I only have 2 behind that load balancer, but I can tell Kubernetes to update all of those microservices carefully in a planned rollout operation, so that after a minute or 2, all of those microservices will be saying bonjour world rather than hello world. Before I do that, I need to push this new version to Docker Hub, right? So that my Google Cloud account can access it. And to do that, I need to say Docker push. Again, I'm pushing it to Lomax account, CloudLab1 version 2. There we go, it's pushing that. And you might not be surprised to see that it's using this cached layered approach. It knows that all the former layers exist already on Docker Hub. It only had to push that outermost layer where I changed that hello to bonjour. So that's now pushed to Docker Hub. What that means is I'm now ready to do a rolling update. And if you do a bit of Googling, you'll find that this is the way to do it. I'll explain what I'm doing in a second. If I say, I think kubectl get deployments. Yeah, I'm now in my Google Cloud Shell, right? And I've just asked to find out what the name of my deployment is. It will actually be in the deployment file. Here is the name. But I can also find out what what its name is by saying kubectl get deployments, and this is the name of my deployment. Now, if I say I would like the image that this deployment is using to be version 2 instead of version 1, then this is the command I need to use. Let's do that. So I'm saying I would like the deployment, this deployment, to use this image instead. And importantly, users are not going to experience any downtime. Kubernetes will take care that the load balancer will redirect to the old versions until the new version is up and running. And then it will start directing users to the new version until all of the old versions have been replaced by the new version. That's sort of called a rolling update, and that's what Kubernetes will now start doing. It says the image has been updated. Again, if I go to kubectl get services, this is the IP. It hasn't changed. I'd forgotten what it was, but this is the IP of the load balancer. If I go to that, it will probably still say hello world because the rolling update, can sometimes take a little. But in this case, we can see that it has already changed, but it's done so in a stable fashion. No users will have experienced downtime. Had I had many of these microservices going, maybe some of them would have seen the old version for a few more minutes until everyone is then seeing the new version, right? But this is one of the huge benefits of Kubernetes. It allows you to do things like rolling updates. Yeah. And let's go back. That means we have completed this journey, created a Go microservice, ran it and accessed it. We then Dockerfied it and ran it using the Docker run command that runs a Docker container on a Linux VM, which we also accessed. We pushed that image to Docker Hub so that we could push and pull it as required. We also created a Kubernetes application by introducing this deployment YAML, and we were able to run that Kubernetes application locally on our laptop using Minicube. Interestingly, the Minicube didn't give us the IP of the load balancer, but we were able to use a Minicube command, this one, to actually access the load balancer. And that did some trickery for us behind the scenes. And we then pushed the Kubernetes deployment to a proper Kubernetes cluster on Google Cloud. That did resolve an IP address for the load balancer that we were then able to access. And then we were also able to modify that Docker image, push the new Docker image to Docker Hub. Tell Kubernetes to do a rolling update to that new Docker image. And then we could see that the rolling update was successful. And then the final step is so that you can use your Docker test account as long as possible and don't use up your $300 worth or $200 worth of credit. What you want to do in the end is, again, go to the hamburger menu, go to the admin option here, manage resources, select your project and delete it. So there we go, delete it, and then you need to give in the project ID without that leading space. And then you're able to shut down this project, and that ensures that you don't burn through the $200 worth. And interestingly, maybe I will get an email shortly on my Gmail account telling me that this project is pending for deletion. Okay, that was a Cloud Lab. Hopefully that made some sense. We'll be happy to give others should you like, but I think for now we hand it back to Sir Maciej.
Yes, I should unmute myself. That works significantly better.
So
thanks a lot, Ken. That was really enjoyable. So now two things for our audience. So first of all, please fill in the form that I will just send you. This is just for us to know how you liked the lecture and what could we possibly improve. And maybe do you have some questions for Ken?
I saw an interesting comment from David. He says, David mentioned he accessed it and did get the other pod. So that's interesting. So that showed that the load balancer maybe is geographically based by default. And that's interesting to hear.
Another question from Jan. How about connection between service and managed by Kubernetes? Like we have DB or any service accessible HTTP, how to connect from different one?
Yeah, well, I think typically you would also have your DB running as a Docker image as well, right? So you'll have your database, your front end, your back end, your microservices, all as Docker images, and they should all be talking to each other. And when you deploy Docker images, when you create this deployment file, these Docker images have names, and those names are used by Kubernetes. You can use those names to talk between services, and Kubernetes will use those names as the DNS names of the URLs. So for example, if you have a database Docker image called my database, you can talk, you can reference that microservice using http://my database. So I don't think I explained that very well, but have a look at the links I've given in the Cloud Labs. And essentially you want to run all your stuff as Docker images. And once that's the case, you can easily deploy them and scale them in Kubernetes.
Okay, now the question from David. Why did we build the Go application at the beginning, but then continued to use Go run instead of the Docker container?
That's an excellent point. Yeah, not necessary. Yes, yes. That's true. We didn't have to. We didn't have to. That was me playing around and not realizing it's not necessary. Mm-hmm. So no good reason there.
Cool. Any more questions? If no, I will now.
I have one question.
Yes, please.
So I built this base Golang web server on my computer and then use LDD to check the linkage. And I saw that it depends on libc and other system libraries. And then my question is, does this base Golang Docker image installs the environment like standard library and system libraries?
I suppose so. I'm not really sure. I mean, it will be a completely, self-contained executable. So if the Docker image itself, the Docker image that you build upon, may well have those dependencies that you were just describing. What you can do is go to Docker Hub and explore. You can go into for example, the Golang Docker image and see how it itself was built. And maybe it is the case that it already has some of these libraries. But yeah, I'm not sure. You'd have to explore that.
Okay, any more questions? David, another question. So what are the best practices regarding running databases in Docker? They are different than web applications since they need a place to store the data.
Yeah, what you would typically do is, I think it's called volume mapping. And that basically, you reserve some memory on Google Cloud or Amazon or Azure, and you can map that volume of memory to a database, and you can do that from, let's say, one. So you have to use what is called volume mapping, but that's really beyond this Cloud Lab. But so Google database Docker images, and you'll find your answers.
Any more questions?